Right now, as you watch this, our entire galaxy is moving through space at an incredible speed, carrying billions of stars along with it through the vast darkness. And over immense cosmic time, this motion is slowly bringing us closer to another massive galaxy. The Andromeda Galaxy, our nearest large galactic neighbor, is also moving through space, and current observations strongly suggest that our two galaxies are gradually approaching one another over billions of years. But what actually happens when two galaxies pass through each other on such a massive scale? And what could that mean for the future of our solar system within this vast cosmic environment? I remember looking through a telescope at Andromeda for the first time, seeing only a faint, distant smudge of light, and feeling a deep sense of calm under the quiet night sky. We often look up at the stars and assume the sky is still, permanent, and unchanged, as if what we see tonight is exactly what existed for countless generations before us. But in reality, that stillness is only an illusion, because the universe is constantly in motion, and that faint smudge is actually an enormous galaxy slowly traveling through space. Today, based on observations and astrophysical models, we can explore how galaxies interact with one another, and how gravity gradually reshapes their structures over incredibly long periods of time. What many people don't realize is that a galaxy interaction is not a sudden explosion, but a slow and complex process that unfolds over billions of years through the influence of gravity alone. Welcome back to Tomorrow's Science, where we explore the universe through observation and understanding. Let's take a closer look at what may happen. One of the most surprising facts about galaxy interactions is that, despite their size, almost none of the individual stars within them are expected to collide directly with one another. Space between stars is so vast that if each star were the size of a small ball, the next one would be separated by hundreds of miles of empty space. Because of this immense distance, what we call a collision is actually a gradual gravitational interaction that reshapes both galaxies over time rather than a direct impact. As the two galaxies slowly move closer together, their gravitational forces begin to stretch and distort their spiral arms, pulling vast streams of stars outward into space. Many stars are gradually shifted from their original paths, forming long, glowing streams that extend between the two galaxies like bridges of light. These structures, known as tidal tails, can stretch across hundreds of thousands of light years, showing how powerful gravity can be on such enormous scales. While stars remain far apart during this process, large clouds of gas and dust within the galaxies can interact more directly as their structures begin to overlap. These interactions compress the gas, and over time, this compression can trigger the formation of new stars in different regions across both galaxies. This period, often referred to as a starburst phase, leads to the appearance of many bright, newly formed stars that illuminate the surrounding space. At the center of each large galaxy lies a supermassive black hole, and during a merger, these massive objects are gradually drawn toward each other by gravity. Over long periods of time, they may orbit one another, influencing nearby stars and gas as they slowly lose energy and move closer together. Eventually, they may combine into a single, more massive black hole, releasing energy in the form of gravitational waves that travel across space. You might wonder what could happen to our own solar system if such a large-scale galactic interaction were to take place in the distant future. Current simulations suggest that it is possible our solar system could shift into a different region of the resulting galaxy as gravitational forces reshape the structure around it. However, because of the vast distances between stars, Earth itself would likely remain physically unaffected, continuing to orbit the Sun as it does today. If such an event were ever observed from Earth, the night sky would appear very different, gradually changing over time as new structures become visible. Instead of a narrow band of the Milky Way, the sky could become filled with the bright and detailed structure of another galaxy stretching across it. It would appear as a complex and evolving pattern of stars, glowing gas clouds, and dark dust regions spread across the entire sky. The central regions of the galaxies would not merge immediately, but instead pass through each other and continue moving before being pulled back again by gravity. Over very long timescales, this repeated motion would gradually slow down, bringing the two cores closer together with each pass. With each interaction, the original spiral shapes of the galaxies would become less defined as their structures are reshaped. After billions of years of gradual interaction, the motion would settle, and the galaxies would form a new, more stable structure in space. Instead of two distinct spiral galaxies, the result would likely be a large elliptical galaxy made up mostly of older stars distributed in a smoother shape. Scientists often refer to this possible future galaxy as Milkomeda, representing the combination of the Milky Way and Andromeda. From a scientific perspective, interactions like this are one of the observable ways galaxies evolve and change their structure over time. Observations of distant galaxies suggest that many of the large galaxies we see today were formed through similar processes over long periods. Let me know in the comments, would you want to witness a changing night sky like this? Subscribe to Tomorrow's Science for more explorations.